All right, we are looking at how to find the area between two curves. So when you do this, you basically will have two functions. The hardest thing is figuring out which function is on top and which one's on the bottom because you're looking for the area between two curves. So, all right, so what I do is I draw this rectangle in between the two functions. And think of the area of a rectangle. It'd be the length times the width. The length would be f minus g. And the width, what we're going to let the width be all this chapter, the width of the rectangle that you choose is going to be delta x because the width changes and it's just some small x. And remember when we first started talking about integration, we tried to get more and more rectangles in our area. And the more rectangles we had, the better the area. And then we figured out, well, instead of putting in a bunch of rectangles, we can integrate f of x minus g of x times delta x, which is d of x. And when you do the area between two curves, you're always going to have a definite integral. You're going to go from one point to another point. So it'd be from A to B. So they're always going to have a value when you do area between two curves. All right, the hardest thing I think is just figuring out what the graphs look like because sometimes they give you a graph and sometimes they don't. If they give you a graph, it's easy to figure out like which one's the top function and which one's the bottom function. So let me give you two functions. F of x is negative x squared plus 4x plus 1, and g of x is going to be x plus 1. Now, they don't even tell you the a and b. If you look at the book example, some of them, they have a picture and so you know what a and b are, your lower and your upper boundary. So what you need to do is figure out a and b by just figuring out where these two functions intersect. And so set them equal to find the points of intersection. And let's see, if I do my algebra, I'm going to end up with x squared minus 3x equals 0. And so that means x times x minus 3. So when x equals 0 and x equals 3, that's going to be our upper and lower boundary because that's where they intersect. Now you have to be careful. Sometimes you might have things that intersect at more than one point. They might have a positive and negative area. So, but those you can do also. You can just do them in two integrals and make them work. So what I do now is I like to graph because I don't know which one is the top function and which one is the bottom function. So I'm going to start with f of x right here. If I put 0 in, I get 1. And by the way, it's good to know that f of x is quadratic, so it should be a parabola that opens down. If I put 1 in, I get negative 1 plus 4 plus 1, so that'd be 4. If I put 2 in, I get negative 4 plus 8 plus 1 would be 5. And if I put 3 in, I get negative 9 plus 12 plus 1, which is 4. So it's going back down. So that means 2, 5 was its max. And if I draw that, that one looks like that. Okay, and then you want to draw your G graph. And if I put in 0, so I'm still going to go from, basically I'm going from 0, 1, 2, and 3 because that's our points of intersection. 0 here. This one's easy, it's just a line. It just goes up by 1. So the area that they want us to find is this area in between the two graphs. So this is my top function. This is my bottom function. And what you do is you integrate from 0 to 3 of negative x squared plus 4x plus 1, and make sure you subtract the whole function. So I'm subtracting x plus 1. So if I simplify that, I'm going from 0 to 3 of negative x squared. That would be plus 3x, and the ones would cancel. And we would then find our answer by integrating negative x cubed over 3 plus 3 halves x squared from 0 to 3. So I'd have like negative 27 thirds plus 3 halves times 9 minus, both of those are going to give me 0, and whatever that equals. So your answer will be numeric for when you're finding the area between two curves. The hardest part with these is just figuring out which one's the top function, which one's the bottom function. The other thing that they throw in here are functions in terms of y, and hopefully you looked at that book example. So let's say that I have f of y equals y times 2 minus y, and g of y equals negative y. And we work with this a little bit in this chapter, so it's good to look at them now before we start doing application problems that are in terms of y. First of all, I'm going to rewrite this as 2y minus y squared. And because y is squared, it means it's a parabola, but it opens actually to the left. Remember, when the y is squared, they either open left or right, and this one opens to the left, so because this is negative. And here, y is just negative y, so it's just it's going to be a line. It's just a little weird to graph. First thing I'm going to do is find my points of where they intersect by setting them equal. So negative y equals 2y minus y squared. 3y minus y squared equals 0. 0 equals y times 3 minus y. So they intersect when y equals 0 and when y equals 3. So then I need some points between 0 and 3. So I'm going to start with this parabola that opens to the left. I'm going to put in, for y, I'm going to do 0, 1, 2, and 3. If I put in 0, I get 0. If I put in 1, I get 2 minus 1, which is 1. If I put in 2, I get 0. If I put in 3, I get 6 minus 9, which is negative 3. And these are x values. Okay, I'm just going to go ahead and do the table for this one also, my g function. Same y values that you're going to start with, 0, 1, 2, and 3. If you put in 0, 0. You put in 1, negative 2, negative 3. All right, and then I'm going to graph because I have to graph to figure out which one's the top function. And when I graph this, I'm going to do in green, I'll do this parabola. So you got 0, 0, 1, 1, 0, 2, and then 3, negative 3, like that. So that's that parabola. It goes like that, sort of. And then in blue, I'll do this one, 0, 0. Oh, that's yellow. That's not blue. Here's blue. 1, 1, negative 1, 1, negative 2, and 3. So you see you got this little area again. Now, when you write the integral for this, it's going to be different. You're in terms of y. So first of all, your top function is the parabola. So this is the top function minus the bottom function. Okay, so you're going to have 2y minus y squared minus negative y, which becomes plus y. So you're going to have the integral of 3y minus y squared. Now, you have to be careful on your lower and upper boundaries because this time, when I draw a rectangle in, how I talked about before, if you draw one rectangle in, your rectangle is not going to go up and down. It's going the lengthways because you're in terms of y. So if that rectangle is going to travel the y values, if you're integrating in terms of y, you need the y values. So my lower y value is 0, and my upper y value, the upper limit of my y, is 3. And then you would integrate that and get your answer. Okay? This is a big part of this chapter, just being able to find the area between those two curves and realizing that if you have a y, if you think about one rectangle in there, it's going to be horizontal. Where if you have an x, which if I go back up to this one, I didn't draw my rectangle in there, but you know how we picked one rectangle. So there's that one rectangle, because we're going to use that one rectangle to represent lots of different things. So it's good to start thinking about, if I pick one rectangle, I had to subtract this top function minus the bottom function times the width of the rectangle, which is actually dx here. Well, if I go down to my y function, the width of the rectangle is the change in y. So it'd be dy in my integral. Okay, the actual calculus is easy. It's just coming up with the integrals. Have a good day.